Hello, my lovelies! It's Susanna, and today I want to show you how to simplify these three expressions here. Let's start with our first example. Write as a single fraction in its simplest form. We have three fractions here, and we want to add these fractions. We can only do that if our denominators are the same. They are not yet, so our first step is to find a common denominator of all these three fractions. If we take a look at the denominators, we see that we have multiplications here everywhere. So there is no plus or minus. So this is the easy part. If you have this in your problem, then you can look at the numbers separately and after that add the variables. So the numbers, we have a 5 here, the 6 here, and the 10 here, and we have to find a common multiple of these three numbers. So we want to find a number that is divisible by 5, divisible by 6, and divisible by 10. To do this, you can always take your largest number, in our case it's our 10, and look at the multiples of this number. So 10, 20, 30, 40, and so on. And then always check if these numbers are now divisible by your other numbers. So is 10 divisible by 5 and by 6? No, it's not, because 10 is not divisible by 6. The same with the 20. 20 is not divisible by 6. But the 30 is divisible by 5, divisible by 6, and of course divisible by 10. So the 30 is our common multiple, and we take the 30 in our common denominator. This is already a part of our common denominator for our numbers. And now we go to our variables. We have to do the same with our variables. We have to add them to our denominator. So we take a look at our first fraction here. We have a y and an a in here, and we have to add both of these variables, all of the variables, to our common denominator. So a y has to be in there and an a has to be in there. That tells us our first fraction. Now we go to the second fraction and see if we have to add more than just these two variables. So here we have an x, and the x tells us, I want to be in the common denominator as well. Am I already in there? No, there is no x in here yet, so we have to add the x as well. And then we have an a here, and this a tells us, I want to be in the common denominator as well. Am I already in there? Yes, you are. So this a is happy, and we don't have to add it again. It's already in here. And then we go to our third fraction and take a look at the variables. We have an x in here. Yes, the x is already in here. We have a y in here. Yes, the y is already in here. So these variables are happy as well. We don't have to add them again. And this is our common denominator. And I add it here now as well. And then we have to take a look at our numerator. We had 2x here, but because we changed things in our denominator, we have to do the same changes now in the numerator. So what did we do? We had a 5 in here, we changed it to 30. So we multiplied this number by 6. We have to do the same in the numerator, so we multiply by 6. What about the variables? We had y and a in here. Y and a are, of course, still in here, but we added this x here, so we have to multiply by x here in the numerator as well. The same here. There was this y, I write down this y here first, but then I have to multiply with our changes. We had a 6 here, we multiplied by 5 this time to get to 30, so we have to multiply by 5 here as well. What about the variables? X and a were in here, so a and x are in here, but this y came here in as well, so we have to add this in the numerator as well. And here the last one, there was an a in here, we write it down, but from the number 10 times 3 equals 30, so times 3 here as well. And x and y were in here, x and y, so we added this a, so we have to multiply by a here as well. Okay, let's simplify this a little bit. From the numbers 2 times 6 equals 12 and x times x equals x squared, we leave the denominator as it is. We worked hard to find it. Here we have 5 times y equals y squared and our denominator. And then the last fraction, we have 3 times a is a squared, and then our common denominator. Okay, this is what we've got so far. Now, we have the same denominator everywhere. We are allowed to add these fractions now. We keep the denominator, and then we add the numerators. So we have 12x squared plus 5y squared plus 3a squared, and that's it. Okay, we solved our first example. What about the second one? Write as a single fraction in its simplest form. This time we have these two fractions and we want to subtract them. We know that we are only allowed to do that if the denominators are the same. Of course, they are not yet, so our job is to find a common denominator again. But we have to be careful because this time the denominators are different compared to our first example. Because here we have a minus and here we have a plus. In our first example, we saw that there were only multiplication symbols everywhere. And if you have multiplications everywhere, then you are allowed to take a look at your numbers separately, and then after that you can take a look at your variables separately. But not if you are working with minuses or pluses. Then the things belong together. So this x minus 1 is one thing. You can also write it in parentheses. We are not allowed to take a look at them separately. They belong together. This is one package. And also if you have a plus somewhere, you know this is one package. So you can write it in parentheses. We are not allowed to take a look at them separately. Okay, but if they are packages and we want to find a common denominator, well, all the packages have to go in the denominator. So we take our first package, it's x minus 1, and we just multiply it by the second package, by this x plus 2, and this is our common denominator then. We just take both packages that we work here with and write them in the denominator. Okay. Let's take a look at the numerators now. We had a 2 in here. What did we change in the denominator so that we have to change the same thing in the numerator now? We had x minus 1 in here. That is this here, but we added this, so we have to multiply by this part in the numerator as well. And here we had the 1 in the numerator. We had this package here already. We added this one, so we have to multiply by this in the numerator as well. Okay, let's simplify these things a little bit. Maybe we get rid of the parentheses here. So we have 2 times x, which equals 2x. Then we have our plus, and 2 times 2 equals 4. We leave the denominator as it is. And with our second part here, well, it's 1 times these parentheses, so it's 1 times x equals x, and 1 times -1 is -1, and we leave the denominator here as well. So this is how our expression looks like now. What now? Well, we want to subtract them, and now our denominators are the same, so let's do it. We keep this denominator here and we subtract the numerators. So we take this numerator here, 2x plus 4, and we subtract this whole other numerator. So write this in parentheses so that you have minus this whole thing. So we have this thing here. let's simplify it even more. We leave the denominator as it is. It looks good. And in the numerator, we can get rid of these parentheses here. So we take the first part, and then we have minus x, so minus x here, and minus -1, so minus and minus is a +1 then. Okay, let's simplify it even more. What can we do? We have 2x minus 1x, which is just 1x, and 4 plus 1 equals 5. And this is our denominator, and then we are done with our second example. Number 3. Write as a single fraction in its simplest form. We have these two fractions here. We want to subtract them, and we know we can only do that if the denominators are the same. They are not, so let's try and find a common denominator. If we take a look at our denominator here, we have a plus here, which means that these things belong together. This is one package. We can write it in parentheses. And here the same, we have this minus here, so this is one package. Let's write this in parentheses as well. For the common denominator, we have to use each package. So we have to take this and multiply it by this one. But before you do this, because here is a lot going on in here, before you just take them as they are right now, always check if you can simplify them first. So try and factor things out. Try to write this as a product if you can. So here, for example, you have this plus here, and we see that we have a 3 in here, and we have a 3 in here. So we can factor out the 3 and write this as a product. This helps us, so let's try it. So we don't search for a common denominator in this step. We first simplify our denominators. So we leave the numerator as it is, and we factor out our green 3 here. And what is left in our parentheses then? We had this plus here. So here, if we factor out our green 3, only the y is left. Then we have our plus. And here, if we factor out this green 3, we have 3 over 3, which equals 1. So we have our product we were looking for, and we try to do the same with the second denominator. So we leave the numerator as it is, and now we try to factor things out. Well, it doesn't work here because there are no repeating elements in here, but we have y squared minus 1. Something squared minus something else. Take a closer look if you might have a difference of squares here. And we do, because the 1, we can write it as 1 squared as well. 1 is the same as 1 squared. So we have a difference of squares here, which is great, because there is a formula on how to write this as a product. If you have something like a squared minus b squared, so a difference of squares, then you can write it always as a product. In one of these parentheses you have a minus, in the other one a plus, and then you just take your variables. A first, then your b, and here the same, a first, and then your b. And this is our product. So we use it here. We write this in parentheses. In one of them we have a minus, in the other one a plus, and then we just take our variables, our y first, then our 1, and the same here, our y first, and then our 1. So here we have this product now, and here we have this product. How does this help us now? Well, we want to find a common denominator, right? Still. And now we only have to take the things once in there. So let's take a look at it. We have a 3 here with a multiplication, so we know the 3 wants to be in the common denominator, so the 3 has to go in here. What else? The next package. This whole package, all of these parentheses, want to go in the common denominator, so we let them go in there. So we take these parentheses, this y plus 1. Let's take a look at the second denominator now. Now we have these parentheses here with y minus 1. They are not yet in here, so we have to add them. We have to add the y minus 1, but we don't have to add this second thing here because y plus 1 is already in the common denominator. So we have to add less things, and things are not going to be blown up. Which is great. So we want to keep things small. So this is our common denominator. I write it down here as well. And then we have to take a look at our numerators because we changed the denominators. We take our numerator as it is, the 4y minus 1. Write it in parentheses because we have a minus here and we know this is one package. What did we change? The 3 was already there. The first package was already there, but we added this package, so we have to multiply the numerator by this package. Okay. Then here we had this here already in the numerator, so we write it down, write it in parentheses, but now what did we add? There was no 3 in there before, so we added the 3. We have to add it here as well. But the y minus 1 was already here and it still is in here, and this y plus 1 was already in here and it's still in here, so we didn't add anything else. This is everything. So now we can subtract these two fractions because the denominators are the same. Finally. So we can write it as one big fraction. We take this beautiful denominator here, and then we subtract the numerators. So we take our first numerator as it is, and then we subtract the second numerator. We don't have to write it in parentheses here again because we have a multiplication here. So we can just take this thing as it is and subtract it from this part here. So now we simplify a little bit. We leave our denominator as it is. We don't change anything there, but we can change some things in the numerator. We can get rid of these parentheses by multiplying each element of the first parentheses by each element of the second. So we have this times this and this times this. Let's start with that. So we have 4y times y, which equals 4y squared, and 4y times negative 1 equals negative 4y. Then a new color, and we do the same with the second element. We multiply this by each element in here. So we have negative 1 times y, which equals negative y, and negative 1 times negative 1, which is plus 1. Then we have this minus here, and then let's multiply this parentheses by 3. So we multiply each element in here by the 3, which means that we have 3 times 1. Let's write the result in parentheses again. So 3 times 1 equals 3, and 3 times negative 2y equals negative 6y. Okay, this is where we are. Now let's simplify it even more. The denominator is great already, so we leave it like this, but we can do some things in the numerator. We have 4y squared, but then we have negative 4y minus 1y. So we have negative 5 of these y's. then we have the plus 1, and then we want to get rid of these parentheses, so we have the minus that we have to put on here and on here as well. So we have negative 3, and negative is positive 6y. Then the last step, we write down the denominator one last time, and then we simplify things here. We have the 4y squared. Then the y's, we have negative 5 of them plus 6 of them, which equals 1y. So we have plus y. And then the numbers plus 1 minus 3 equals negative 2. And this is our result. I hope it helped you. If you have any questions, please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care.